Hello, my name is Eric Sheridan, Chief Scientist at WhiteHat Security. In this demonstration, I will show you how to integrate security testing directly into the Postman API lifecycle using a series of technologies that we call API Security Tester. API Security Tester is both a public workspace and a public collection that allows you to perform security testing directly within Postman using WhiteHat Security's patented intelligence-directed DAST technology. For this demonstration, we're going to be using an open source application called JuiceShop. The authors of JuiceShop describe it as probably the most modern and sophisticated insecure web application. So here we have an application that contains a number of purposefully introduced vulnerabilities. It is also a single-page application backed by a number of APIs. Now let's assume that we're developers of this application. More specifically, we're developers of a subset of the APIs served by JuiceShop. In order to make sure those APIs are functionally correct, we make use of Postman to both write and automate the execution of our suite of functional tests. To that end, I actually have a test up and running over here via this collection called JuiceShop Search. This gives me the ability to search for products within JuiceShop. And by way of example, here's a test that when I run will verify that I can indeed search for apple juice. Now, this test passes. So I know that the API appears to be functionally correct. What I need to know is the API also secure? I need to perform a security test of that API. To do that, let's go ahead and follow the documentation for the API Security Tester collection. Now, the first thing it's going to ask us to do is to set up intelligence-directed DAST, also abbreviated IDD, by running a Docker container. If I expand the instructions, I'm actually given the two commands I need to run. So the first one is a Docker pull command. That will make sure that my laptop has the latest version of the image. The next command I'm going to run is Docker run, where it'll actually start the container. Now, before I actually execute this command, I will highlight that by executing this command, I am accepting the end user license for IDD. For more information on the end user license, we provided a link in the documentation for this collection. Let's go ahead and click enter. And we can verify that the IDD API is up and running if we get this message that says listening and serving HTTP on 27374. Excellent, so I'm all set up. Let's go back to the next step in our documentation here. The next step says that we need to export the collection that we wish to test. Now in this demonstration, I want to test the APIs represented by this JuiceShop search collection. So let me go ahead and export this collection to a file. Now I'm going to export it to collection version 2.1, but it really doesn't matter what format you export it to. As long as it's supported by Postman, it's supported by API Security Tester. Once I click export, the file is actually stored locally onto my laptop in the downloads folder. Excellent. Let's go back and see what we need to do next. Next, we need to actually configure our scan by reviewing and editing the submit scan job request. So if I go to submit scan job and click the body tab, this is where I enter the inputs for the scan. The first input says input files. And here I can actually select what file or files I want to submit for security testing. Now in this case, I'm submitting a Postman collection that I want to use to help drive the security testing. The Postman collection file that I'm using is self-contained. But if you had environment variables or external variables referenced in that Postman collection, you could also add additional input file rows and submit those as well. Let's go ahead and click select files, and I will select the Postman collection that I just exported. And I will click save. The next entry on this request is allowed hosts. The allowed hosts parameter tells IDD what hosts you are okay with it performing security tests against. The default value is localhost. So what this means is that anywhere in this Postman collection, if there is an API running on localhost, IDD will test it. If, however, there's something running on, I don't know, foo.bar.com, for example, IDD will not test it because you did not specifically say it is an allowed host. Now, what's nice here is the default options will work for me, so I'm going to go ahead and click Save. I'm good to go. Now, let's go back to the documentation and see what happens next. After configuring the scan, we need to actually run the scan using the collection runner. Now, let's go back to our API security tester and click Run. This is the collection runner interface, at which point all I need to do is click Run API Security Tester. Now, while this is running, it will actually poll the API to determine whether or not the scan has completed. So right now the scan is running. It is actively testing those APIs in JuShop for security vulnerabilities. If I scroll down, you can see that the security test is finished. So within seconds, we have some feedback. We can verify that this passed and that this succeeded because the number of tests that passed were 3 out of 3. We had 0 failed tests. And at the very bottom, it says it successfully displayed the scan results. And we simply need to head on over to the Visualize tab under Body to triage the results. So let's go to the Display Scan Results request and click Send. When we click Send, this is actually going to get back the latest copy of the results of the scan that I just completed. If you look down here at the bottom, you can see JSON representation of the scan results that were generated by IDD. If you click the Visualize tab, you're going to be given a graphical representation of the vulnerabilities that are discovered. More importantly, it gives you the ability to triage the vulnerabilities directly within a Postman in a way that it almost is a native Postman user experience. Looking at the security report, if I scroll down, you can see all the vulnerabilities that were discovered sorted by severity. So it looks like within a few seconds, 7 vulnerabilities were discovered. And right at the top, we have a critical SQL injection vulnerability that was discovered in an API with the path of REST products search. If I drill down into this vulnerability, I can get more information, including the fully qualified path to the API, the actual field that was attacked. I can read about SQL injection and why this vulnerability is so particularly dangerous. I can also get insights into how to go about fixing SQL injection in the actual source code itself. Now, if I have any question as to whether or not this vulnerability is truly exploitable, all I need to do is look at the evidence provided to me by IDD. Here, IDD provides me a screenshot of exactly what it saw when it performed its security testing, which serves as proof that the application is exploitable and vulnerable. In this case, JuShop saw a very verbose database error message indicating that the syntax of the query was malformed. That's because IDD was able to modify the query into something triggering the error, and in the future it could actually lead to someone else exploiting this vulnerability at scale. So as a developer, I have confidence that the vulnerability I'm looking at is a true positive. No time wasted triaging false positives. If I scroll down further, I'm also given access to just-in-time micro lessons that teach me in very 2 to 3 minute bite-sized videos about the vulnerability. In this case, I have a 2 to 3 minute video describing how to fix SQL injection when it matters most. That is, I learned how to fix the vulnerabilities as they are discovered directly in my API when I'm trying to fix them. So in 2 to 3 minutes, I will fully understand how to go about preventing this vulnerability in my API. Armed with all this information, I have everything I need to go back to my API and implement the security fix. Once I implement a fix in the source code, I need only rerun this test using API Security Tester to verify that the vulnerability was properly fixed. Now, with that said, that would conclude the demonstration. I would like to highlight a couple key things before we go. First, you'll notice that the totality of this demonstration was within Postman. The entire testing experience is within the Postman environment that we all know and love and use today. The other thing I'll highlight is that the API security tester workspace and collection are public. They're accessible today. So please, by all means, give it a shot. Let us know what you think. Thank you for your time, and we look forward to hearing your feedback on API Security Tester.